These places shouldn't be standing. Massive rocks balanced in ways that defy logic. Boulders frozen mid-fall. Entire formations that look like someone placed them there on purpose. And the higher we climb on this list, the harder it becomes to explain them. In this countdown, we're exploring 13 of the strangest natural formations on Earth. Places so unusual, they challenge what we think we know about geology. And by the time we reach number 1, you may start questioning whether nature always plays by the rules. At first glance, Chiricahua looks like a forest made of stone. Balanced rocks stacked vertically, some taller than a building, resting on bases that seem far too narrow to support them. These formations began as volcanic ash 27 million years ago. Over time, erosion sculpted the soft rock into columns, hoodoos, and gravity-defying towers. It's a reminder that geology isn't always explosive. Sometimes it's patient. But the real question is, why do some rocks survive erosion in such precise, almost architectural shapes? And speaking of architectural, the next rock looks like it was designed to tip over. Idle Rock in Yorkshire looks like it's moments away from rolling down the hill. It's perched awkwardly on a slanted base, defying your sense of balance. The entire Brimham Rocks area was carved by wind, rain, and ice over millions of years. But here's the curious part. These sandstone formations were once buried under miles of sediment. The strange shapes we see today are what survived, which raises a quiet geological truth. What looks unnatural is often just what resisted erosion the longest. And in Spain, erosion created something even more surreal. El Torcal doesn't look like a natural landscape. It looks stacked. Layer upon layer of limestone piled into strange formations that resemble stone pancakes frozen mid-collapse. But this landscape began underwater. Around 150 million years ago, this entire region was part of a shallow sea. Over time, marine sediments accumulated and hardened into thick limestone layers. Then tectonic forces lifted the seabed upward, and that's when the real sculpting began. Rainwater, slightly acidic by nature, slowly dissolved the limestone along its fractures. Wind widened the gaps. Time exaggerated the shapes. What remains is not random chaos. It's structural erosion. Flat layers fracture horizontally. Water seeps between them. Gravity does the rest. The result feels architectural, but it's simply chemistry and pressure working patiently over millions of years. And if stacked stone feels unusual, the next rock in Utah looks like it's wearing a perfectly balanced hat. Mexican Hat Rock doesn't just look balanced, it looks staged. A wide, flat slab rests delicately atop a narrow sandstone column as if gravity paused mid-decision. But this formation is a lesson in differential erosion. The upper rock layer is harder and more resistant to weathering. The base beneath it is softer. Over time, wind and water remove the weaker material around it, except for the one column strong enough to hold. What you're seeing isn't a rock placed on top of another. It's what survived. And here's the quiet geological truth. Balanced rocks aren't rare because they're unstable. They're rare because most eventually fall. This one simply hasn't yet. And Norway gives us a rock shaped so precisely by the ocean, it looks carved by a sculptor. Cannisteinen looks like an hourglass carved by design. The top is broad, the bottom is narrow, which feels backwards. But coastal erosion doesn't work evenly. Wave action constantly strikes the base of the rock, especially during storms. Salt water penetrates cracks. Freeze-thaw cycles widen them. The lower portion weakens faster than the upper section. Over centuries, the base thins while the top remains relatively intact. The result looks intentional, but it's selective erosion at work. It's also a reminder that gravity is patient. Given enough time, the top will eventually collapse. It just hasn't yet. And in Jordan, wind sculpted something even more dramatic. In the desert of Wadi Rum stands a massive stone mushroom. Its base looks too thin, its cap too heavy. But desert wind is relentless. Sand carried by wind acts like natural sandpaper. Over thousands of years, the lower portions of rock formations are blasted more aggressively because sand particles bounce near ground level. The upper portion experiences less direct abrasion. That's why the base narrows. It's physics, airflow patterns, particle impact, material resistance. Yet visually it feels unstable, like it shouldn't survive the next strong gust. But it has endured for centuries. And Finland offers something even more puzzling, a rock that barely touches the surface beneath it. Kumakivi translates to strange rock. The name is honest. A massive boulder rests on a curved slab of bedrock, touching at only one small point. You can't push it. You can't rock it. It feels temporary, but it has remained stable for over 11,000 years. The explanation lies in glacial transport. During the Ice Age, thick ice sheets moved across Finland carrying enormous stones embedded in their base. When the ice melted, these rocks were gently lowered onto exposed bedrock. The contact point may be small, but the center of mass keeps it balanced. It looks accidental, but it's physics. Australia has dozens of strange boulders like this, only much larger. Scattered across Australia's Northern Territory are massive granite spheres known as the Devil's Marbles. Some sit alone, others appear stacked. They look placed, but they formed deep underground. Granite expands and contracts as it cools. Over time, internal fractures develop in patterns that isolate rounded sections of rock. As erosion removes surrounding material, those rounded cores are exposed. Pressure release causes further cracking, sometimes splitting the spheres cleanly in half. What you're seeing isn't a boulder shaped from the outside, it's a core revealed from within. And in India, gravity faces one of its most photographed tests. Krishna's butterball sits on a steep slope in Mahabalipuram. It weighs over 250 tons, and yet it hasn't rolled. For centuries, locals have tried to move it. Even elephants were reportedly used in attempts. It didn't budge. Geologically, it's another glacially deposited boulder that survived erosion of surrounding material, but its center of gravity aligns perfectly with the contact surface beneath it, which is why it remains stable. It looks impossible, but it's a balance of mass distribution and friction. Spain, however, offers something far more imposing. Peñón de Ifac rises out of the Mediterranean like a mountain placed in the wrong location. There's no gradual slope, no transition from coastline to peak. It simply shoots upward from the sea. This limestone mass formed millions of years ago beneath an ancient ocean. Layer after layer of marine sediment compressed into rock. Later, tectonic forces lifted it skyward as continents shifted. But what makes it feel strange isn't just its height, it's the isolation. Over time, erosion stripped away the softer surrounding terrain, leaving this single monolith standing alone against the coast. It feels intentional, almost defensive, yet it's simply what survived. A reminder that sometimes the strangest landscapes aren't created by addition, but by subtraction. And if a solitary mountain feels unnatural, the next formation looks even more unstable. Balanced rock looks like a mistake in physics. A massive upper boulder rests on a thin pedestal of sandstone, and instinctively you expect it to fall. But geology moves slowly. The top rock is more resistant to erosion than the base beneath it. Wind and rain gradually wear down the pedestal, grain by grain. What you're seeing isn't balanced by accident, it's balanced by resistance. Similar formations nearby have already collapsed in recent decades. This one simply hasn't reached that moment yet, which makes it strangely temporary. It feels permanent, monumental, but in geological time, it's a brief pause before gravity wins. And now the number one place on this list takes that same idea of impossible balance and adds something even more mysterious. Golden rock doesn't just look unstable, it looks impossible. Perched on the edge of a cliff in Myanmar, this massive boulder appears to be defying gravity, barely touching the rock beneath it. Unlike the others on this list, this one carries deep spiritual meaning. For centuries, it has been covered in gold leaf by pilgrims who believe it remains balanced by divine intervention. But geologically, the explanation begins with glaciers and erosion. The boulder itself is likely a transported rock, left behind as surrounding material wore away. Its center of mass aligns just enough with the contact point below to keep it stable. What makes it unsettling isn't the science, it's the margin. There's almost no visible base, no reassuring foundation, just a rock that looks like it could fall at any moment. But it hasn't. And maybe that's what makes the strangest places on Earth so compelling. They look like they shouldn't exist, yet somehow they do. Some of these places seem to challenge gravity, but there are landscapes on Earth that go even further. Places that don't just look unstable, they look completely unreal. If you thought these were strange, wait until you see the 9 places that look fake but are absolutely real.